we first need to find the condition that will prove that this actually is converging. Okay, and so we actually need to use monotonic sequence theorem, which says every bounded monotonic sequence is convergent. Okay, so that means, first of all, this is bounded by something. Okay, so obviously it's starting from 2, right? So it's either an increase or decrease. And so if you plug in, if you try to find A2, it's increasing. A2, it's, what's it, half, 2 plus 6, it was 4, right? And I think if you find A3 in the same way, 4 plus, you get 5, and then you start to get closer and closer to 6. You have to clearly define our condition. The condition is the following. Okay, 1. Remember we said if you show that it works for, the condition works for like the initial case, and also you show that it works for some end case, then it works for all cases, right? So the condition that you must satisfy is that it's increasing. 2, it's always bounded. Okay, so it's bounded, let's say it's, our intuition tells us it's bounded around 6, right? But let's just say it's bounded to number some L. That's, like, let's say that's L is greater than or equal to 6. We try a bunch of this and they all seem to be getting like 5 point something, very close to 6. So this is a pretty good assumption. Now, the first case, from A1 and A2 is equal to 4. This is the initial case. Clearly, both of these conditions are true. It's increasing, true. And is it lower? Is it bounded below 6? Yes. That's also true too, right? Okay. Step 2 is to say, well, let's assume that both of these are true for AK, let's say. AK is true, let's say. And our goal is to show that it's also true for AK plus 1. Okay. So AK is, what's the given formula here? It'll be half. Okay, no, actually, let's assume this. Let's assume AK is greater than AK plus 1. This is assumption. Okay. We don't need to prove it. We just need to show that, must show the next one. This also is true. AK plus 1 is greater than AK. And you have to do this with only the given information. So what is the given information? This condition, okay? So here's what I'm going to do. I'm going to try to make both sides look like, I want this to look like to get to here. Let's start from AK is greater than AK plus 1. Oh, sorry, this is minus 1. Sorry, I meant minus 1 there. AK is AK minus 1. So first of all, attached to AK is a plus 6. So I'm going to add 6 to both sides. And then what's after that? Times both sides by half, right? You're allowed to do that with the inequality. So what I'm doing here is just algebra, right? I'm just taking this assumption and manipulating it. This must be true. Since we are assuming this is true, every line must be true right now. Okay, and this is by definition AK plus 1, isn't it? And this is by definition AK, isn't it? So if this is true, we assume that this is true. This is also true. So we showed it for case, and we show that if you assume case work, the K plus 1 case work. Okay. So that essentially proves, right? That essentially proves there is a limit to AN which is approaching L. Okay. By mathematical induction, we say by mathematical induction, AN is approaching L as n approaches to infinity by this monotonic sequence theorem. We've shown that it's capped and it's always increasing. Okay. So what is that value? What is that value exactly? We have to go back to this. Is it 4? 6. Here, we assume that both of these are approaching the same place. They both are upper bounded by L, right? So then we can say, well, this is 2L is equal to L plus 6, so L must be 6. Just as we suspected it. Okay. Now this is something that you do after you prove that it is going to get there. Okay. So I'm again here assuming that AN is approaching L. I first need to prove that it has an upper bound. Okay, so this is the upper bound. Okay, so just watch this video again if you're a little bit loose on the what is it exactly you need to do to use mathematical induction properly. You have to show, you have to clearly define, this section sometimes it's hard. You have to clearly define what this condition is and how you have to check it for the base case and then show that it also works for the next case after you assume it's AK.